Yo, Chuck.
Hey, what's going on YouTube? In this video, I'm going to show you how to move a character on your tile map, and we're also going to do some collision detection. So here we have a tile map, just like the video I made before. The black is zeros on the map, and the 1 are represented by the gray. So you can see it right here, and that's what that looks like. So right now it's kind of ugly, so I want to pretty it up a bit. So I'm going to make a class for the walls. Notice the walls are the zeros here. So I'm going to say class wall. It's going to have a constructor. And basically, I want to pass in an x and a y value inside of every wall I make. So I'll say this.x equals x and this.y equals y. And I'm going to use the draw image function on the canvas to pretty much make those walls and draw them every iteration. So let's make a draw method, and I'll just say let image equal new image, and then I'll say image source. And I have this wall PNG right here, so I'll use that. Let's do something like that. Okay, and then I'm going to draw it onto my canvas. So we'll say context draw image, and then I'll pass in the image that I just created right here. And then I'm going to use the this.x and this.y. So whatever I pass in right here when I create my wall will be the x and y used to draw it. So now that we've got that in place, I can actually come in here where I'm drawing the black tiles and get rid of that, and let's do let wall equal new wall, and I'm going to pass in the x and y values that I was using before. So that would be this tile width times column for my x value, and then tile height times row is my y value. And now we can call wall.draw. Let's see if this works. Excellent. So now we're drawing walls, and you can see we've got walls here. And we're also recording the x and y position of each individual wall, which is pretty nice. So I could actually just console.log. This is going to spam the console with the properties of each wall. But let's take a look. You can see as the draw map function is firing, each individual wall that's being drawn, we're recording its x and y coordinates, which is good. Okay, so that's pretty much how to fancy up the walls. The reason I'm doing this and recording the x and y values is because later I want to pretty much do some type of collision detection with my character. Let's refresh this. Okay, cool. And I don't know why it's still going. Let me exit out of this. Oh, geez. Okay. There we go. Yeah, it was kind of frozen, I think. So, got our walls ready. Now let's add a character. So I'm going to make a character. I'll say const or class player. It's going to have a constructor. Same thing with the wall. We need an x and a y. And this.x will equal x. This.y will be whatever we pass in for y. And it's worth noting, if we want our collision detection work, with the algorithm I'm going to use, we need a height and a width. So let's set our height to like 20, okay? And then let's set our width to 20 for this character. And also, let's make a draw function here. Same thing as the last one. I'm just going to copy this code. Copy this code here, and I'll say night. You can see I have the night PNG right there, and I'll pass in night right here. Actually, I think it's just image. That'll work. Okay. And then again, to get that wall to work, with the collision detection algorithm, I'm also going to pass in a height and width. So this is going to be 48 by 48. My night character is going to be 20 by 20. So now let's create that night. So I'm going to say const player equals new player. I'll pass in the x and y coordinates I want. Let's start at 0, 0, so the top left of the canvas. And notice this draw function. Nothing's going to appear just yet because I need to draw the night each iteration of my update function. So I'll come back to this update. And right after draw map, I want to say player.draw. And there is my night. Okay, looking good. And actually, I think he's a little bit bigger than this. I'm going to put him as 48 by 48 because I'm pretty sure this image is a 48 by 48. Okay, so we've made our night. He's on the field. We need to be able to move him. So let's make some add event listeners to listen for arrow keys. So I'm just going to come in and say window add event listener key down. So every time we press a key down on the keyboard, we're going to fire this function here. And then I'm also going to have a event listener for key up. So whenever a key is released, something's going to happen. And remember, whenever you have an event listener, you get access to that event object. So I'm going to name that event object just E for now. But I also want to make a keys variable because what I'm going to do with these event objects that are returned, I'm going to use them to trigger Boolean flags. So I'm going to know if my key is pressed down, it'll say true. If my arrow key is not pressed, it'll be false. So let me show you what I mean. I'll say arrow up is false, arrow down, false, arrow left, false, and arrow right, false. Okay, so I have this keys variable made, but let's see what happens when I print out the event object when I press a key down. So just to show you, now I'm pressing a key, and notice it's recognizing, hey, you're pressing arrow left, and I have access to all these properties and methods of the event object. Okay, so the one we're concerned with is this key property, because I'm going to use that. See how it says arrow left? I'm going to use that to trigger my flags on my keys object and set it to true. So if I was to console e.key when I press, you'll see it's allowing those arrow keys to move up and down. So I'm going to now use this to set keys to true. So whatever arrow key I press, I want that value to be true. And then if I release that key, I want it to be set to false. So let's console.log keys when we press down on an arrow key now. Let's press it a bunch, and you can see I'm able now to record multiple clicks. Let me see a good example. Looks like it's setting everything to false because I'm releasing it. But if I was to hold it down, let me try this again. There we go. So I guess it's changing it to false after the fact because I'm releasing it, obviously, to show you this. But if I held down, maybe? Okay, so I'm holding down the arrow key down. Now you'll see it's true. Okay, so that works, and we're going to use those keys to manipulate our player's X and Y position. So let's go back to our player class we made, and now let's make a move method. And this is pretty much going to listen for those key flags from being triggered. So I'm going to say if keys.arrow up equals true, you could say equals true, or you could just leave it like this. I prefer this way because it looks cleaner. It's basically saying if the keys object property arrow up is truthy, then you want to do something. And the thing we're going to do is take our player.y property, and we're going to decrement it by, let's say, player.speed. And I have it made a speed, so let's say this.speed equals 2. So we're going to decrement our player speed by we're going to decrement our y by player speed. And then conversely, for the arrow down, we're going to do the same thing, except this time we're going to increment our player speed. And this seems kind of counterintuitive, but just remember, if you're going up on the screen, technically your y value is getting less. And if you're going down on the screen, like in this instance, your y value is getting greater. So that's why we're decreasing our player speed when we want to go up. So now let's do it for arrows left, player.x. So if we're going to the left, that means that our x value is getting less. So we want to say less than or equal to player.speed. And then for arrow.right, it's the same thing, but inverse. So player.x plus equals player.speed. Okay, so we've made this move function. This is going to help us move our character with the arrow keys, but I still need to call this function in our update. So after we draw the player, we want to run move, right? Let's see what happens now. Cool, and you can see my guy is able to float around freely at player speed, which we set to 2. So that's kind of cool. Notice how I'm able to go out of bounds. Let's fix that real quick. So the way we can fix that, we just got to think about our movement function here. So if we are going up, we don't want to go past 0 because 0 would be the highest point on the canvas. So I could say, and player.y is greater than 0. Now this should allow us to move up to a certain point, but I'm stopping. See, I'm trying to go up, but it just stops me now because if I'm less than 0, I will no longer be able to move up. So that's how we fix the up condition. Now for the down, we want to be always less than the canvas.height. Otherwise, we shouldn't be able to go down anymore, right? But let's see, there's going to be an issue that comes up with this. So, whoops. Oh, see, I forgot to put a and player y is less than canvas.height. All right. Okay, so now when we go down, see if you can understand what the issue is. We still go off the screen. So why are we still going off the screen? Well, we need to account for the height of this character here. And we can do that by minusing the canvas height minus player.height. Or I guess I could say this.height actually would be better. So now if I go down, I should clip, yep, and I can no longer just go all the way to the bottom like that. So that's cool. Let's fix the left. The left is really easy. All you have to say is as long as player.x is greater than 0, because 0 is the furthest left point on the screen. So now if I try to go to the left, I'll stop. And if I try to go to the bottom, I'll stop. But if I go to the right, I'll still go off the screen. To fix that, we can say and player.x is less than canvas.width, because the canvas width is going to be the greatest point on the right-hand side. But remember, we have to compensate for our character's width too. So say this.width. So we're subtracting out the width of our character here so it properly clips against the screen. Again, if I didn't compensate for that, now I'll go off the screen, okay? So leave that minus dot width in there, perfect. All right, so that was the fun part. We got all the borders fixed. Now we want to do something with these walls. How can we get our player to stop hitting these walls and messing it up? Okay, so The collision detection algorithm we can use, there's actually a bunch of them, but I just Google this really common one. So let's go to just JavaScript 2D collision. And this article gives you this pretty good one right here. So you don't even need to really understand all the logic in this collision detection algorithm. You can just copy and paste it. So that's what I'm going to do here. Let's go to our wall, and let's pretty much have our wall detect if the player is hitting it. So I want to go to my wall class. Come down here, and let's say is collision, some type of method we can create. I'll paste in that code. And basically, I'm going to say if, and I'll put all this code inside of the if statement. So if this is true, what do I want to do? I want to just alert something like collision. Okay, perfect. And this is why it's important to pass in a height and width value for both your player and your wall, because you can see in this algorithm, it's using X and Y values as well as height and width, okay? So I'm actually going to change the W on this algorithm to just say width instead, because that's what my classes have. Now, you can do an easy way to select all of these is just hold down the command on the Mac or control on the Windows and then hit D. And notice now I have multiple cursors, and I can just type in width here. I'm going to do the same thing for the height. Use the command D, type in height. Cool, so now our properties and our classes are synced with this algorithm, and I can just pass in something right here. So is collision, I'm going to pass in player, and I'm also going to pass in this, because this is referring to the wall itself. Player is referring to the player object that we make down here. So back in my draw map function, I want to call wall dot is collision. So let's see, let me make sure I did this right. Okay, this actually should be rect1 and rect2. I knew something felt weird, because you're passing in rect1 and it's going to be applied to this algorithm. Same with rect2, but down here we want to actually pass in the wall and then the player. Okay, so let's see if this works. Close this, and you can see collision. It's letting me know, hey, you hit the wall, and it'll keep letting me know. Let's do a console log instead, so it's not so intrusive. Console.log collision. I just want to do this for testing purposes and make sure everything works good. Collision, 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 collision. Okay, cool. So that's working. This is like 90% the way there, but we still need some type of way to like stop our guy from going into the walls. Now there's different ways you can do this, and I've experimented with a few, but I think I found a really good way that I like to use here. And what we can do actually is we can record the previous X and Y value of our character, and if he hits a wall and collision is detected, we can set our X and Y values at the point of collision to the previous value that he was at before he collided. So what we need to do is go back to our player class, and let's make a this.previous x equal to null, and this.previous y equals to null. And now I want to make a method that's going to update these previous values. So I'll say get previous x and y, just a method like that. And I'll say this.previous x equals this.x. And this.previous y equals this.y. Okay, so right now it's just going to be mirroring pretty much what the x and the y is. But here's the trick. On our animate function, the update now, wherever it is up here. So I'm going to call that method before I actually move my guy. So I'll say player dot get previous x and y. So I'm going to call that method before I actually move, because remember, the movement method is actually updating my x and y. So if I call this beforehand and grab my x and y, it'll be the previous. So now that I have this value stored, I can come down here to my collision detection function I just made. Let me just find it. Okay, there it is. So instead of collision, I can say player, because remember I'm passing in the player here. I could say .x equals player.previous x, and then player.y equals player.previous y. And you know what? Let's keep in that console.log of collision, just so I can kind of show you. So now you can see I'm triggering collision, but my guy will just stop. He'll stop when he hits a wall, which is really nice. And like I said, there's other solutions to this problem in a tile-based game, but I found this one to be kind of cool. And notice you might want to decrease the size of your sprite here so it doesn't clip the walls. And you can even increase your speed. Like, I might increase my speed just to see what it would look like. Let's say equals 3. Pretty cool though, right? Like you can clip walls and it's going to detect it. So I think that's pretty sweet. That is a collision detection on a tile-based game, and I showed you how to move the character. So I hope you guys enjoyed this video, and I will see you in the next one.